All right, this module is about statistical quality control. The only problem with quality is it depends on the person, right? So you might say a car has good quality because it gets good gas mileage, seems to last a long time. Another person might say it has good quality because it has leather seats and good paint job and all of that. So typically what we want to say is that quality is when a product delivers what is stipulated for in its specifications. In other words, what they said it was going to do, it meets or exceeds customer requirements now in the future. We can have product quality versus process quality, where we might be looking at the actual design versus conformance. And then we have the different quality dimensions where quality in goods, we might be looking at the performance, features, reliability, and so on, versus quality in service, where we might be looking at more of tangibles. So cost of achieving good quality, cost of prevention, employee training, quality planning, cost of appraisal or detection, beta testing, inspections. Remember that. I remember seeing this in the quiz. And then, of course, you're going to have the cost of failure, internal failure cost. You might have to scrap something, start over, even the time that it took to start over, do a rework. External failure cost. A lot of companies have these warranties that come out and bring your car back in. The brakes are bad, all that kind of stuff. Even might have to set up a new call center if they're getting too many complaints. And then, of course, the cost of lost business, which you can't really measure, because if I tell somebody, I'm never going back to that store again, one, you don't know how many people I told or how many people it actually affected. And then business came up with this term, this total quality management, TQM, where now we're not going to just look at, a particular section of the company. We're going to look at the entire organization as a whole. So we're going to look at leadership, which of course we want to be strong, employee involvement, product process excellence. We want to continue to improve, and then of course customer focus. And many different tools to do this. You're already familiar with scatter diagrams. Probably some of you have seen Pareto charts, flow diagrams. We're going to talk a lot about the statistical process control charts. So those are going to be the ones we're going to focus on the most. When I was working for Dell Computers in Austin, it was, kind of funny because that was the first time I heard about the Six Sigma. And in fact, you can go, if you're really interested in this, you can go, and get certified. And kind of funny, they have different belts, like blue belts, green belts, black belts, and all that. But basically, an organization wants to be able to be defect free. And so a lot of times they will either put together within their company, like Dell did. Some places will go out and actually hire an outside company, but to ensure that they're meeting all of these requirements, okay, that they actually stated. And so one of the biggest things they want to do is certainly reduce process variation and provide a framework and methodologies to ensure that they're putting out what they say they're going to do. So reduce variation is huge, right? Because you want to have consistency in your actual products. As I mentioned, we're going to focus on some different types of charts. I'm going to kind of just flip through here and leave it to you to read through these, because I'm going to actually do some examples of the ones that you're going to need. So it talks about these control charts. We're going to look at the X bar and R charts, just barely mention the control charts for compliance P. The P chart is basically where your product inspection has no measurement. In other words, it might be pass or fail or yes or no. And this is just graphing the proportion of samples, proportion for P, that are non-compliance. okay? But we're going to focus on the X bar and the R, where you have a center line based on an R for range, X bar, as you know, for the mean, and we have an upper limit and a lower limit, these control limits, that basically tell us if something's going wrong. And so the X-bar control chart is, as it sounds like, you're going to have a bunch of different samples. You're going to get the means of all of those samples, and then the main mean, okay? And a lot of times they call this X double bar, so the mean of all of these, and that's going to be your center bar. And there's different ways you can do these. The design, if you have a very large sample, we like to be within 3 standard deviations. If you remember the empirical rule, if you're within 3 standard deviations, then, certainly that's the majority. You're staying where you need to be. Sometimes, though, for small sample sizes, like 5, 6, 7 samples, we might use the actual range, and that's what we're going to do in my example. So as I mentioned, I'm going to show how to do all of this. So I kind of leave it to you to read through these, but we're going to have a sample. We're going to find the average for each one, then we're going to find the range for each one, and you're going to see it. And I'll mention this in the Excel, that there's a table in the back of your book, but don't worry if you don't have the textbook, I put it in Excel, where you actually find these factors for control charts. And then next we're going to do an R control chart. Again, this is measuring variation, because with this one we're talking about the range. So it plots the variation of each sample. And in this case, the center line is the average range. And we're going to have these factors as well. All right, so let's just go ahead. I'll leave it up to you to flip through the rest of these slides. But let's go ahead and actually see how to compute some of these formulas for these X bar and R charts.